We need to take a look at and discuss here the idea of a negative area. What the heck does that actually mean? A definite integral can be positive, negative, or zero. If it's negative, then it cannot be used to represent area. There's no such thing as a negative area. I don't know what that means. So let's consider f of x equals x on negative 2 to 1. Well, that's a pretty easy one to draw here. Here's 1, here's negative 1, negative 2, negative 1, negative 2. It's going to look like this. So the area below the x-axis is negative. So if I were to integrate this thing, this area, and I should put that in quotes, the area below the negative x-axis is negative. It's not that the area is negative, it's that when you integrate this, this will give you a negative contribution. When you integrate from 0 to 1, this will give you a positive contribution. See, this is negative 2, this is 1, just so you understand exactly where we are here. So this area as such, and like I said, you need to kind of put that in quotes because you can't really interpret it as area, but it will give a negative contribution, and anything above the x-axis, the area between the x-axis and the function will give you a positive contribution. Now, if what I wanted was to actually find out the true area, if I want to know the actual area, between the curve and the x-axis, then what I need to do, if I integrate from negative 2 to 0, that's going to give me this negative area, so to speak, right? It's going to be negative contribution. So what I want is the negative of it. Seeing this will be negative, taking another negative of it, that's a double negative. That gives me a positive. So that's like taking the absolute value. It's like looking at this, which will have the same area but positive. And then add it to the integral from 0 to 1 of f of x dx. See, a few minutes ago in another video, I talked about the idea of integrating from a to b of f of x dx plus the integral from b to c of f of x dx. That's kind of important because that's what we did. We broke this up, and I'm looking at different intervals, and then I'm going to combine those intervals to actually find the actual area between the curve and the x-axis. So in this example, it would be negative 2 to 0 of x dx plus the integral from 0 to 1 of x dx. Now, we would not actually integrate this. We could find this area geometrically because this is just a triangle. And so we could find these two areas, and we could actually solve it. I'm not going to do it here, but it'll only take you a few minutes to figure out the height and the base of this triangle, and for both these triangles. Calculate that area and add them up together. Now, where this may be important as it was before I started looking for the actual area in between, suppose this was a profit-loss function. If I integrate this as it sits, simply the integral from negative 2 to 1 of x dx, obviously there's more negative area here, again in kind of quotes. They have a bigger negative contribution. So this is going to end up being negative. That implies a loss. See, I'm not considering this area. It's actually this integration is giving me the total profit. And the total profit's negative, meaning a loss. Total profit here is positive, meaning a profit. The loss overruns the profit, so this would give me a negative net result. So I should actually say net area as net result. Which, if I have a physical phenomenon such as, well, profit and loss, then it would make sense. It would tell me if I'm in the red or if I'm in the black.